Okay, today is November 1st, and what we're talking about is absolute value equations. So let's look at the first one here. The absolute value of x minus 4 equals 2. Well, first you have to ask yourself, is there anything to isolate? And what I mean by that, is there anything around the absolute value symbols other than what's inside the absolute value? As we look at this one, no. You only have the absolute value of x minus 4. You'll see some examples later where that'll make more sense because you will have to isolate. But since you don't have to isolate here, you look at what it equals. Well, it equals a positive number. What that tells us is we're going to have two answers. Well, how do we get two answers? It's simple. First, you make this x minus 4 equals 2. We no longer need the absolute value symbol. But since we have to have two answers, we also set it at x minus 4 equals negative 2. And now we simply solve both. Over here we do the inverse operation. The opposite of minus 4 is plus 4. 2 plus 4 equals 6. So x equals 6. And then we come over here. The opposite of minus 4 again is plus 4. Only difference now is negative 2 plus 4, which equals 2. So x equals 6 and x equals 2. Okay, now let's look at the next problem. The absolute value of x minus 3 minus 4 equals negative 2. Is there anything to isolate? Is there anything around these absolute value symbols, or this absolute value symbol, that is not inside of the absolute value symbols? Yes, this minus 4 is here. So we want to isolate the absolute value symbols by itself, so we have to move this minus 4 away. The only way to do that is to do inverse operations. The opposite of minus 4 is plus 4. Negative 2 plus 4 equals 2. So now we bring everything down, and what do we have left? X minus 3, or the absolute value of x minus 3, equals 2. Now this is similar to the first problem we had. At this point you look to see what it equals. It's a positive number, so you know you're going to have two solutions. It's very important for the students to understand the only time you look at what it equals to make that determination, you have to already do the isolation process. In this one, we didn't need to isolate, so we could look at what it equals, a positive number. Here, we've already isolated, so now we have x minus 3 equals 2, or the absolute value of x minus 3 equals 2. So, we're going to do the same thing that we did in the first one. X minus 3 equals 2, and x minus 3 equals negative 2. Here we do the inverse operation and add 3. So x equals 5. And we come over here and add 3. Negative 2 plus 3 equals 1. So x equals 5 and x equals 1. Now let's look at this example. Once again, is there anything that we can move to isolate the absolute value symbols, or what's inside the absolute value symbols, by itself? Yes, there's a 2 here. This reads 2 times the absolute value of x plus 5 equals 8. So what's the inverse of multiplying? Divide. So we're going to divide this 2 on both sides. And what do we have left? The absolute value of x plus 5 equals 4. Now, it's just like the other two problems. X plus 5 equals 4. And we also have x plus 5 equals negative 4. Subtract 5 here on both sides. Come over here and subtract. So we have x equals -1 and -9. And we could always come up here and check. -1 plus 5 equals 4. The absolute value of 4 is 4. 4 times 2 will give us 8. Or we could plug in -9. -9 plus 5 is -4. Absolute value of -4 is 4. 4 times 2 is 8. So our answer here is -1 and -9. One more example. This says the absolute value of x minus 4 plus 4 equals 4. We have something to isolate, so we're going to subtract 4 from each side. Now we have the absolute value of x minus 4 equals 0. Whenever it equals 0 after you isolate, that lets you know you're only going to have one answer. So x minus 4 equals 0. We're going to add 4 to get x by itself. 0 plus 4 is 4. So x would equal 4. Now, after you isolate, if you ever end up with a negative after the equal sign, right after you isolate, then the answer would be no solution. Please leave me a comment if you have any questions or concerns. Thank you.